Imagine this. You're snug in your seat, ready for takeoff, when suddenly your phone starts to ring. Panic ensues as you fumble to turn it off. Imagine the relief when you finally switch it off, only to be followed by a chorus of laughter from those around you. Yes, it's an all too familiar scene for many of us. But the mirth aside, there's a serious reason behind this seemingly harmless act. You see, during the crucial stages of takeoff and landing, the pilot is in constant communication with air traffic control. They're navigating the skies, making sure your flight is smooth and safe. Your phone, tablet, or laptop? They're not just devices. They're tiny radio wave transmitters. And these waves, while typically harmless, have the potential to interfere with the aircraft's communication and navigation systems. So, why exactly are we asked to turn off our devices during takeoff and landing? Let's find out. Ever wondered what airplane mode actually does to your device? Most of us click it on without a second thought when we buckle up for a flight, but there's more to this little airplane icon than meets the eye. Airplane mode is a feature that essentially transforms your phone into a mini, non-transmitting electronic device. When activated, it shuts down all the transceivers in your device. That means no calls, no texts, no Wi-Fi, no Bluetooth, and no GPS. Your device goes off the grid, so to speak, becoming a self-contained unit that doesn't send or receive any signals. But why does this matter? Well, it's all about radio waves. All electronic devices, whether they're smartphones, tablets, laptops, or even smartwatches, emit radio waves. These waves are part of the electromagnetic spectrum, just like visible light, but they have much longer wavelengths and lower frequencies. When you send a text or make a call, your device emits these radio waves, which then travel at the speed of light to the nearest cell tower or Wi-Fi router. Imagine these radio waves like ripples in a pond. When your device sends out a signal, it's like dropping a stone into the water. The ripples spread out, carrying the information from your device to the receiving antenna. It's an invisible process, but it's happening all the time, every time you use your device. Now, these radio waves are usually harmless. They pass through walls, they pass through us, and they pass through the air without causing any trouble. But when we're talking about an airplane, flying thousands of feet in the air at hundreds of miles per hour, the situation becomes a bit more complex. So what does this have to do with airplane mode? And why does your flight attendant insist on you turning it on? The answer lies in the potential for these radio waves to interfere with the airplane's communication and navigation systems. But how do these radio waves interfere with an airplane's operations? Airplanes rely heavily on radio frequencies for communication and navigation. Imagine this. You're cruising at 35,000 feet, surrounded by nothing but clouds and the open sky. Your pilot, the person responsible for your safety, is relying on a complex dance of radio waves to communicate with air traffic control and navigate the aircraft. Now, let's introduce your smartphone into the equation. Every electronic device emits radio waves, and your smartphone is no exception. When you're using your phone, it's constantly sending and receiving signals, creating its own symphony of radio waves. But what happens when these waves clash with those crucial for flight operations? The concern here is that strong radio waves from electronics could potentially disrupt the signals used by the aircraft. For instance, your phone signals could interfere with the Global Positioning System, or GPS, making it harder for the pilot to navigate. This is particularly important during takeoff and landing, the most critical phases of flight when clear communication and accurate navigation are paramount. A minor disruption could potentially lead to a major problem. It's important to note that modern aircraft are designed with shielding to protect their systems from such interference. But as the saying goes, better safe than sorry. It's always a good idea to minimize any potential risk, however small it may be. And remember, it's not just about the aircraft. Your phone signals could interfere with other devices in the cabin, such as medical equipment. It's a chain reaction, where one small disruption can have a ripple effect, impacting not just your flight, but the safety of those around you. So it's not just about the aircraft, but what about the cellular networks down below? High above the ground, your phone is on a relentless quest for cell service. It might seem harmless, but this tireless search can create what we call cellular congestion. Let's break it down. As we speak, your phone is like a lighthouse, sending out signals in all directions, hoping for a response from a cell tower. It's a bit like shouting out into the wilderness and waiting for an echo. When you're on the ground, this works perfectly. Your phone's signals are strong, and the cell towers are close by. But when you're tens of thousands of feet in the air, things get a little more complicated. Your phone's signals have to travel a lot further to reach a cell tower. As a result, they aren't as strong when they finally arrive, making it harder for the towers to pick them up. Now imagine hundreds of phones on the same airplane, all sending out these weak signals at the same time. It's like a chorus of voices all shouting out into the wilderness. This cacophony of signals can overwhelm the cell towers, causing a sort of traffic jam on the cellular highway. This is cellular congestion. But the impact doesn't stop at the aircraft. This congestion can also affect the ground-based cellular service. It's like a ripple effect. When the cell towers are overwhelmed, they can't handle the normal volume of calls and texts. This can lead to dropped calls and slow data speeds for everyone in the area, not just those on the airplane. So the next time you're tempted to sneak a text during your flight, remember the potential chaos you could be causing. It's not just about your one text or call. It's about the collective impact of hundreds of devices all trying to connect at the same time. And that, my friends, can lead to a whole lot of cellular congestion. In aviation, safety is always the top priority. From the meticulous maintenance checks before each flight to the rigorous training of pilots and crew, every detail is geared towards ensuring a secure journey across the skies. This principle of safety extends even to the humble request from your flight attendant to switch your devices to airplane mode. It may seem like a small detail, but it's a necessary one, as it ensures clear communication and navigation, especially during critical phases of flight such as takeoff and landing. Now, you might be wondering, does my one device really make a difference? Well, consider this. If every passenger on a plane thought the same way, we'd have hundreds of devices potentially causing interference. That's why it's not just about your one device, it's about the collective impact of all the devices on board. To give us more insight into this, we reached out to some aviation experts. Captain Smith, a commercial pilot with over 20 years of experience, shares, "In the cockpit, we rely heavily on our instruments and communication systems. Even a minor glitch can be a distraction. That's why it's so important for passengers to follow the crew's instructions, including switching their devices to airplane mode." And it's not just pilots who echo this sentiment. Dr. Jones, an aviation technology researcher, adds, "As technology evolves, so does its potential to interfere. That's why the aviation industry is always cautious. It's not about the likelihood of interference, it's about eliminating the risk, however small it may be. So next time you're on a flight and the crew asks you to switch to airplane mode, remember that it's about more than just following rules. It's about playing your part in the safety of everyone on board. But what does the future hold for airplane mode? As technology evolves, so do the regulations that govern its use. The future of airplane mode is no exception. With the rapid advancement of technology, we might soon find ourselves in a world where the need for airplane mode is obsolete. Imagine a scenario where our devices have the intelligence to adjust their signals, making them compatible with aircraft systems. Or consider a future where aircraft are designed with advanced shielding, rendering them impervious to any potential interference. Perhaps one day we'll even see the birth of a new generation of devices, specifically engineered for air travel, with inbuilt features that ensure seamless operation without disturbing the aircraft's communication and navigation systems. The possibilities are indeed endless. As we navigate this exciting future, one thing remains certain: safety will always be paramount. But for now, airplane mode remains an essential part of air travel. Thanks for joining us on this journey through the airwaves. We've navigated the mysteries of airplane mode, explored the potential for radio wave interference and cellular network congestion, discussed the crucial role of safety during flights, and even peeked into the future of airplane mode. It's clear that airplane mode is more than just a switch on our devices. It's a commitment to safety, a nod to effective communication, and a contribution to the smooth operation of our beloved aviation industry. If you've enjoyed this flight of knowledge, give us a thumbs up. Want to continue exploring the skies with us? hit that subscribe button. Know someone who could benefit from understanding why we go dark during takeoffs and landings. Share this video with them. So the next time you're jetting off somewhere, remember, don't panic, just put it in airplane mode.